Mm, last time the paper was too difficult. I mean, uh, those are possible questions. Though I mean, though those are possible questions, you cannot expect everything in one paper. Right? So here we have four in the first and four in the second. Right. But if you want to aim at performing really well in A levels, you need to go through past papers, right? No matter which papers you do, like you have to take like one type, say for example, inequalities containing modulus. That's the second question. You at least do from 2016 to 24. That would be good enough for math. For math, doing papers before this uh, may not be very profitable because those problems may not appear now. But in physics and chemistry, you better do from 2010 or possibly 2000. But here the structure the structure was changed twice or three times, three times. Therefore, no point of doing problems before 2016. Hmm. If you do these things, you will be in really good shape. I mean, I'm stressing this point because of the following reason. Uh, Now, you have only, I think, gone through, in physics, you have gone through only mechanics. Probably you have started waves and oscillations and waves. But basically, uh, you are done with mechanics only. Similarly, in chemistry, you have covered only 15% of the entire syllabus. Right. Once everything is done, it will be like a lot of subject matter is there. So it's extremely hard to memorize or do every problem from every section. Because if you study one section, you may forget something else. Therefore, if uh, in every paper, uh, even though this is the syllabus, the examination department has a certain not regulations, but they have certain regulations. But other than that, they have certain guidelines. Right? According to those guidelines, some parts are not tested. Right, that's the reason. Some parts are not tested. Only from the entire syllabus, nearly 40%, 50%, right, of the matter is tested. Because of that, you need to figure out those content. I mean, that content. If you're familiar with that content, uh, I mean, rather than memorizing a bulk, you can memorize it effectively. You can memorize කරන්න බෑනේ. එහෙම කරන්න බෑ කාටවත්. Past papers කරොත්, like if you go through the past papers, you see that every problem like concentrates on a specific point. The point is right? That's all what you need to do. In A levels, to be successful, that's all what you need to do. But nearly, there are about 1% of people, students, like say in Candy, probably 20, 25, they can handle any bulk. There are, special guys, special girl, I mean, students who can handle any amount of subject matter, but it's not for everybody, right? If you want to do it effectively, you have to learn this, master these things, and you need to know a little bit of the other stuff, right? To figure that out, what to be mastered, you have to go through past papers and see, because every time, in math, all 34 questions will be on specific topics. Even in physics, there'll be 50 MCQs. In those 50, all the time, specific 50 points are, uh, those questions are based on 50 specific points. If you figure out those points, you are done. It's extremely simple. You don't have to know everything, right? So to figure that out, when you learn theory, like you don't figure out what they are. You simply do homework and everything, and you try to master everything. Probably 6 or 7 months prior to the exam, you find it extremely hard. You feel like it's overwhelming. ඒක එච්චර වැඩි ඒක ඊට පස්සේ කරගන්න බෑ. ඒතර එතකොට මේක too late. එහෙනම් දැන් ඉදම් පාස් පේපර්ස් කරලා මේ ටික මාස්ටර් කරගත්තොත් වැඩි ලීසි. ඒතර ඔයගලන්ට බල්ක් එකක් දැනෙන්නේ නැහැ. මේක කරන්න පුළුවන් අයින්ද මේ අපේ ක්ලාස් එකේ තියෙනවා එහෙම කරන්න පුළුවන් අය. but it's not for everybody. ඒ බල්ක් එක කරන්න අමාරු මාරු ගොඩක් තියෙනවා. කෙනෙක් කරලා ෆුල් ටච් එකේ තියාගන්න බෑ. ඒක හැම එකම නිකන් අහපු ගමන් ඕන කොනකින් ක්වෙස්චන් එකට උත්තර දෙන්න බෑ. because it's extremely hard. Because the subject matter is too much. ලංකාව විතර හොම් බල්ක් එකක් තියෙන වෙන countries වල එහෙම නැහැ. like say London A-level for example ඒකේ කොටස් වලට කඩලාන කරන්නේ. in the university again the same thing. Now earlier in the university we had annual exams. Now it's based on semesters, so like biannual. So 50% of the subject matter, and on top of that you have midterm exam. So one quarter of the subject matter covered in entire year will be tested. So it's extremely easy for them. Like everything is probably based on 80 hours of subject matter covered in the lectures, but here it is 1,800 hours. That's why it's overwhelming. So you have to figure out the exam. You have to play the game in the most effective way. දැන් මේ වගේ දැන් අපි ක්‍රිකට් පිච් එක ෆීල්ඩර්ස්ලා සෙට් කරද්දී අපි කියමු දැන් මෙතන බෝලර් ඉන්නවා කීපර් ඉන්නවා ඒතුළු 9 දෙනා නිකන් 40 degrees වලින් තියන්නේ නැහැ නේ because this is altogether 360 degrees 40 degrees වලින් 9 දෙනා තියලා බෑ shots වලට තමයි ප්ලේස් කරන්නේ ඒ වගේ අපිත් ඒගොල්ලන්ගේ shots වලට තමයි ඒ කියන්නේ prepare වෙන්න ඕන. ඒ කියන්නේ මේගොල්ලෝ අහන තැන් වලට තමයි අපි prepare වෙන්න ඕන. You have to master that part, but you need to know the other stuff like kind of like in a shallow level, you need to know the other stuff. But you have to master the points that are tested in the paper. මොකද සමහර MCQ එන්න පුළුවන් දෙක කෙමිස්ට්‍රි වල like 30 to 50 අර එහෙම මෙහෙම එන්න පුළුවන්. හැබැයි ඔයගොල්ලෝ මාස්ටර් කරොත් කොහොමත් ඇවරේජ් එක 80 තියාගන්න පුළුවන්. අර පේපර් එකේ අහන ටික මාස්ටර් කරොත්. 80 තිබුත් ඇති ඕන යුනිවර්සිටි එකට යන්න පුළුවන්. 80 ඇවරේජ් එකක් තිබ්බොත්. right okay. My papers are I think it's a little unfair, but after that I don't ask those type of stuff. I always in every question I give you something that will be tested in the exam paper. There's another thing. Now in O levels, term tests go hand in hand with the final exam, O level exam. But in A levels, that's not the case. Term test is something else, and the exam you get something totally different. ඒතර ටර්ම් ටෙස්ට් වලට විතරක් ප්‍රිපෙයාර් වුණොත් ඔයගලන්ට අර්ග මිස් වෙනවා. මොකද ඒකේ තියෙන්නේ ටර්ම් ටෙස්ට් එකේව නෙවෙයි. Like if you try to in a way it's better to prepare for the exams, term tests. However, if you try to do that, only very few people will be successful because in the term tests they always ask from these areas which are not relevant in the exam most of the time. Like say when you cover like rigid body, they ask lot of questions from rigid body, but you get only 1.25 worth problems from rigid body. But in the applied paper, like probably the third term, you may get nearly 40% of marks for rigid body. Like very unequal like emphasis is given for that. Right. Anyway, we'll start with the first problem. Even though this problem is the first in this paper, in actual paper, this will be the second problem. Modulus functions. Okay. We need to sketch. We need to sketch these two, right? Now, this is a V. So you have to figure out the vertex of that V. It occurs when the modulus function becomes 0. So x is 0. When x is 0, y is equal to 2. So you are here. So this side it is x plus 2. You replace this by x. In this side it is minus x plus 2. Now, second, 2 times x minus 5. Now, what is sitting in the modulus function becomes 0 when x is 5. But after that, if you plug in 5, this will be 0. However, because of this 2, it is multiplied by 2. Therefore, the gradients are larger. Here, the v is little sharper. And on the other hand, when x is 0, on the y-axis, the point of intersection is what? When it is 0, 2 times modulus of minus 5, which is 10. So it's up there. So it will be like this. The gradients are like 2x. Here, this one makes an angle of 45 with the x-axis. Because of these two, it will be like 63. So this side, it is 2 times x plus 5. This is 2 times 5 minus 6. Now, there are 2 points of intersection. You need to find these two. And on the other hand, you need to solve this. That means this guy should be greater than that. So that should sit atop the other one. So here, you have to consider this region and also this region. Here, this graph stays on top of the other. So you need to figure out A and B. To find A, you need to solve these two, this arm and this arm. So write A plus 2 is equal to minus 2 times. This is not minus 5, yeah, this is an arrow. 2 times, 2 times 5 minus A. So this is A, this is 2A. If you bring that, this will be 3A. So 10 minus 2, 8. Sorry, 803. B, you have to solve these two. B plus 2 is equal to 2 times B minus 5. 2B. I bring that B to take that B to the other side. It will appear as B. This is 10 minus 10. If you bring this, it will be 12. Hmm. Yeah. So the answer is this, minus infinity to A to 12. Right. Then the problem on limits. Now, even though this question appears here as the second problem, in the actual paper, this will appear as the fifth question. Hold on, this is wrong. 4. This kind of difficult, when you do it, you better save your space. Now you have to multiply this by its conjugate, and you have to multiply this guy by its conjugate too. Oh. I first multiply this by its conjugate. I can write this in terms of sine. So 2 sine squared and divide this angle by 2. You have to multiply the upstairs by these conjugates. Now basically that's it. Now you better simplify these guys at once. What is this? A minus b times a plus b. So this is a squared minus b squared. The square of this is x plus 1. So x plus 1 minus 1 is just x. So in the same fashion, this is also x. Basically, it's x squared. You better now these guys are not equal to 0 when x is 0. You separate them from this. Now, when you encounter something like this, if you pull out 2, like it is sin x over x, sin x over x. So you write 2 in front. It's kind of easy. This is sin x over x quantity squared. Now, use the properties of limits. You pull out, this step is important. Huh? Pull out 2, write this. You can just write one limit for these two. Because we evaluate this just by substitution. Now this is 1. When you plug in 0, you get 1 plus 1. If you plug in 0, you get 2 plus 2. This is 4 times 2 times 2. 16. You have to prove this. Cos theta in terms of t and sin theta in terms of t. You can write cos theta using half angles. Divided by 1. Now for 1, you can write cosine squared plus sine squared. Divide each and every term by cosine squared. Because then only you get sine over cosine. If you want to write it everything in cot, you have to divide it by sine. But here you have to divide everything by cos squared. So if you do that, this will be tan squared. I mean sine squared over cosine squared. I mean, you can write cosine squared beneath everything. You don't have to. Because this is a first paper question. So it should be, you have to provide the answer in limited space. So divide everything by cosine squared. This will be 1. When you divide this by cosine squared, you get sine or cosine tan, so tan squared. This is 1. Now, this is t. Similarly, use half angle formula again. Now, for 1, you write sine squared plus cosine squared. Sorry. Now, divide everything by cosine squared. This is 1. When you divide this by cosine squared, you get tan squared. When you divide this by cosine squared, you get this. cosine square, na? One will go away. One will go away. It leaves you with sine over cosine, which is tan. This is square, right? Now replace everything by t. Right. Can you take that down quickly? Uh, I think last time we didn't do a problem on vectors, so we do it now. Let I mean, two vectors are given, and they are the position vectors of A and B. We have to show that AOB is 90. The position vector is given with respect to a certain point. Now, the position vector of A is I plus 3j. The position vector of B is 3 alpha I minus alpha j. No matter what alpha is, we have to show that they are perpendicular. How can you do that? Always, if you want to show an angle, you have to use the dot product, right? Dot product. So dot should be equal to 0 if they are perpendicular, because the dot product is given like this. I mean, it's given like that, where theta is the angle between these two. So if you want to show that they are perpendicular, that means theta is 90. You have to show that A dot B is 0. Always, I mean, A dot B being equal to 0 implies they are perpendicular. On the other hand, if the two vectors are perpendicular, the dot product is 0, right? So we'll take the dot product. Now, this is a position vector. That means it is OA. Dot 3 alpha I minus alpha j. Now we can take the dot product. This is how you take the dot product. I dot I is 1, because mod I times, there's no angle between these two. So cos 0 is 1. It is like this. I mean, you get that in this fashion. I dot I cos 0. Both are equal to 1. Similarly, j is also 1. However, I dot j is 0. I dot j is 0. Now we'll go for the dot product. I dot I, it's 1. So 1 times 3 alpha. 3 alpha. I dot j 0. So you can ignore that. J dot I 0. J dot j is 1. However, you get 3 times minus alpha. This is 0. However, you can easily get the dot product because of this. You better justify your answer. But if you don't have enough space in the first paper, you can ignore it in the first paper because only 1/3 of an A4 paper is provided for that. So if you feel like you are running out of the space, don't write that. Otherwise, you better do that. Huh? So they are perpendicular. Since the dot product is 0, this angle is 90. AOB is 90. Now, let C be a point such that OACB is a rectangle. Okay, so we'll see. Here alpha is greater than 0. So I plus 3j should be somewhere here. I mean, it should be corresponding to the coordinate 1, 3. Here alpha is negative. So I plus 3j. Sorry, alpha is positive. So x coordinate is positive, y coordinate is negative. So it will be like this. Now, OACB should be a rectangle. Should be like this. This is also 90. So it's basically a parallelogram. And it's given that C is on the straight line y is equal to x. Anyway, we first find OC. You can choose any triangle, say AOC. You know, OC can be written like this, OA plus AC. Now, AC is equal to OB. They are parallel, same direction and everything. Huh? Magnitudes are the same. So OA is I plus 3j. This is 3 alpha I minus alpha j. Now you can gather these two. This is 1 plus 3 alpha times I. Now, if this is on the straight line, y is equal to x, what does that mean? Now, anyway, if you have a vector like this gives you the x coordinate of the point. This gives you the y coordinate of the point. For example, here the coordinate is 1, 3. Here the coordinate is 3 alpha minus alpha. Likewise, uh, if this is the coordinate corresponding to C, and it says that C is on the straight line, y is equal to x. Now, this is that line, right? What can you say? If you take any point on this line, the y coordinate is equal to the x coordinate. Now, this is the x coordinate of the vector, this is the y coordinate of the vector. So these two should be equal. If it is like, say, y is equal to 2x, then what happens? You take this multiplied by 2. So you get 2x is equal to y. So when you multiply this by 2, it should be equal to this. When it is y is equal to x, simply they are equal. For example, the problem says, for example, let it will be like, it is like that. Let the problem be defined like this. Say, okay, you find C, say C is on this line. How do you tackle that problem? Say C is on y is equal to 1. Means you can ignore this, just make this equal to 1. This is y. I mean, these are simply the coordinates. That's what you need to understand. Hmm. Since it is on y is equal to x, since c is on this line, these two should be equal because y is equal to x. In fact, this is x. Y is equal to x. So make alpha the subject. This will be 4 alpha is 2. So alpha is half. Right. I have made a mistake with the second problem, I guess. I first do that correction. I mean, I think somewhere instead of 2, I wrote something else. Handling these things were fine, right? My explanation was correct, but I made a numerical mistake there. This is in fact 2 sine squared. You have to divide this by 2. Handling these things were fine. Then I multiplied this by the same 2. Uh, Downstairs, you get x and x. Upstairs, you have, here you get x plus 1 plus 1. I mean, don't do it like that. Since I did this part correctly, I didn't want to repeat it. I mean, I don't want to repeat it. That's why I did it like this. Now, this is x squared. Uh, Now you can rearrange these things. Pull out, I mean, pull out the constants you see. Here you have a 2. Now this is how you have to arrange it, rearrange it. I mean, there are other ways of doing this, but this may be the easiest. Now I'm not, look, you can see 2 inside. Now it is in sine squared. So it means sine 2x times sine 2x. So you get 2, so 2 squared. Now simply write, I mean, don't change the angle, keep it as it is, but introduce the same angle in the downstairs. And since it's a square, it should be like that. And these two are equal, because we have x squared here in both cases. you have 2 squared, and it will go away with this. It leaves you with 2 in the upstairs. Now here. Now this 8. You pull out 8. Now plug in 0. Now here it is 8. This is 1 squared. When you plug in 0, you get 1 plus 1, which is 2. If you plug in 0, you get 2 plus 2. 4 times 2, 8 times 8, 64. Earlier I omitted this 2. Right. Sorry about it. Now we'll go for the next. First, I'll do 7a. Most of you found it difficult to cope up with that, the fact that there are no stationary points. X is not equal to 2 and minus 4. Now we'll differentiate this. You have to square the downstairs. Start with the downstairs, I mean v, multiply by the derivative of this, which is 1, minus x plus 1 times the derivative of this. Right. Here you have x minus 2 times x plus 4. Now x minus 2 times the derivative of that, which is 1. You don't have to write it. Then x plus 4 times the derivative of this. The derivative of this is 1. So you don't have to write it. I mean, multiplication by 1 is redundant. Now we'll expand this. This is x squared plus 4x minus 2x means plus 2x minus 8. This is 2x plus 2. 2x plus 2, right? Now you can pull out 2 from here. So you get x plus 1 times x plus 1, which is x plus 1 quantity squared. Now you can expand. So you get, okay. Now x squared minus 2x squared gives you minus x squared plus 2x minus 4x, right? 2 times 2, 4. So minus 2x, 8 minus 2, minus 8 minus 2, minus 10. Now you can pull out a minus sign. Now you can complete a square. write the square root, divide this number by 2. So you have x squared plus 2x plus 1. X squared plus 2x plus 1. So you need extra 9 to get this. Minus sign is sitting outside. Now that is f dash x. Now determine axis intercepts. So when x is 0, y is, you have to find the values of y. When x is 0, what is y? When it is 0, you get 1 times minus 2 times 4. When y is 0, upstairs, you have to consider only the upstairs, no matter what this is. If this is 0, the upstairs should be 0. Just take that. If it is 0, if it is some other value, then you have to consider everything. This can be 0 only if the upstairs is 0. Now you will end up with minus 1. X is minus 1. So there are two axis asymptotes. When x is 0, y is minus 1 over 8. When x is minus 1, y is 0. Right? Now go for vertical asymptotes. Vertical asymptotes occur when the downstairs is equal to 0 or when y is not defined. There are two such values, 2 and minus 4. There are two vertical lines. Then go for branches at infinity. You divide, in the downstairs you have x squared. So divide both factors by x. So 1 minus 2 over x, 1 plus 4 over x. So we have divided now both by x. That means we have divided the downstairs by x squared, not by x, because we have divided this by x as well as this by x. So twice. That means x squared. So divide the upstairs by x squared. When you divide this by x squared, you get 1 over x. Now, when x goes to plus or minus infinity, what happens to y? Now, when this is infinity, this is 0, 0, 0, 0. So 0 over 1, because this is 1, this is 1. 0 over 1 is 0. When it is minus infinity, again the case is the same. 0, 0, 0, 0. 1 over x and 1 over x squared are both 0. So by doing so, you can write it. So there are two asymptotes. This is the branch at infinity. Now finally, stationary points. Now we have to show that y does not have stationary points. How can you do that? At stationary points, f dash x should be 0. Now, this is a rational function. So the upstairs should be equal to 0. So same argument. So x plus 1 squared minus plus 9 is equal to 0. You can, there are two ways of arguing this. If you want, you can write it like this. Now there are no real values for which this is satisfied because this side is greater than or equal to 0. This side is minus 9. Oh, sum of two squares. This non-negative, this positive. This can be 0 when x is minus 1. But still it is non-negative because it's a square. This greater than or equal to 0 plus 9. It cannot be 0. So there are no real values for which this is satisfied. Or you can hit this line and say there are no real values. Hmm. Since x plus 1 quantity squared is greater than or equal to 0 for x in R, uh, there are no real values. I mean, this side is non-negative, this side is negative. You cannot find x's. Therefore, no, there are no stationary points. I mean, you can say there are no real values for x, for which this is satisfied. That means there are no stationary points. Now we'll sketch the graph. Now there are two points that you need to consider because this is not equal to 0, right? So there are two factors. One is at 2, the other is at -4. 0 is somewhere here. So you can sketch you can draw the vertical line there. You better mark the ranges. Now, what are the signs in this range? Now, when x is greater than 2, I mean, these are positive. All the time, these are positive. Huh? These two are positive because they are squares. Only at these 2 points, they are not they are 0, but in those ranges, they are positive. These also positive. Therefore, everything is positive all the time. However, the negative sign in front make everything negative. Hmm. No matter what the value of x is, it's always negative. Because if you look at this as a negative value, when you cross this over, 2 is there. It's a even powered factor. Therefore, no sign change at this point. Again, negative. For the same reason, this is negative. So it is decreasing. All the time it is decreasing. Okay. Now mark the lines. These are the vertical asymptotes. The horizontal asymptote or the branches at infinity is 0. Now you have to mark these points. That's all. -1, 0. -1, 0. So x is -1 here. Y is 0. And there's another point. 0 -1 over 8. When x is 0, this -1 over 8. Y coordinate is -1 over 8. Now look, it is decreasing. So start from here. It is decreasing because this is a vertical asymptote. It is again decreasing, but it should go through these points. Here also again, because you cannot sketch it from here like this. It is decreasing. Hmm. Okay. Some people have difficulties in 6B, so we'll do that. A, B, C, D, E, F are the vertices of a regular hexagon with a side of length 2A. Okay, we'll do a diagram and see what we can do. Right, side length is 2A. Now the forces with magnitude 3, 4P, 10Q in Newton are acting along these directions. Along AB, the first force, 3. Then the second one, BC, it is 4 Newton. CD, it is P, there is something unknown. DE, DE is 10. And Q, it is FE, this way. Now there are two cases. We have to find P and Q if the system of forces reduces to a couple. If it's a couple, means something like this. It can be represented by equal and opposite forces acting on two different lines of action. Right. Therefore, it will be something like that. No matter along which side you resolve them, it will be 0. Right. So if you resolve it in this way, x is 0, y is 0. However, if you take a moment about some point, g is not equal to 0. So to show, you have to go ahead with that condition. Right. So here we'll take this as x. Don't mark R there. We have to show that if it is 0, we have to find P and Q. You can take these two as zeros. Because it's given that it's reduced, the system of forces is reduced to a couple. Now, we have to resolve this. Now, this angle is 60. Since it's a regular hexagon, every angle is 60. Right. Now, if you resolve it, x is equal to 3 plus 4 cos 60. This minus minus 10. This is plus q cos 60. Now cos 60 is half, right? It is half. Now this is 0. We can simplify these two. It is minus 10, minus 7. Now this is 4 times half. P times half plus q times half. You multiply everything by 2 and bring that 7 to this side. It is 14. When you bring that to this side, plus 7. When you multiply it by 2, it is 14. Now this is 4 minus P plus Q. We have multiplied everything by 2. So if you bring that 4 to this side, it will be 10. Now do the same thing vertically. I mean, resolve the forces vertically. Y, and these two will not come into play. So this is 4 sine 60. This is 4 cos 60. This is 4 sine 60. 4 sine 60. This is P sine 60. This is Q sine 60. This is 0. You can divide everything by sine 60. So you get 0 is equal to 4 plus P plus Q. Now, if you add these two, you can get rid of one of them. P will go away. 6 is equal to 2Q, so Q is 3. If you plug in one value here, for Q, you can find P. Minus 4 is equal to P plus 3. Minus 7 means it's in the opposite direction. Basically, that's it. Hmm. Now, the second case, okay, this says that the resultant is acting along AD. So what can you do for this? If the resultant is acting along A and D, you can simply take the moments about A and D. Now the moment about this is 0, this side, because it's acting along A. On the other hand, the moment about D is also 0. Somehow you have to come up with two equations to figure out P and D. Sorry, P and Q. Oh, there's a longer way of doing it, but it's not, I mean, it's not useful here. Like, you can resolve the forces this way. It is R, this angle is 60, right? If you resolve them, it is R cos 60. If you resolve forces to this side, it is R sine 60. And then what is the ratio? R cos 60 over R sine 60 means tan 60. Using that, you can again do it because you don't have to resolve them again. You have them right there. That's also another way of doing it. If you don't want to take moments, too many moments, I mean, just take one moment about A and do it in the other way. That's another possibility. Hmm. Now we'll see how to take the moments. Now there are four forces, right? Now the length of the side is 2A. I mean, here the angle is 120 here. Everything is 120. So if you extend this should be 60. I read 3 and somewhere here, right? 60. So if you drop a perpendicular, this 90, this 30. So you can find this length. Similarly, if you extend this, you can, this 60. If you drop a perpendicular, this is 30. So you can find the perpendicular distances to these forces. Now here, this is 120, right? These two are these two have the equal lengths, 2A and 2A. So if you draw a line like that, what happens? This is an isosceles triangle. So this is 120. So sum of these two should be 60. So that means this is 30, 30. Right? This is 30. So using that, you can find the perpendicular distance to that. If you use the same argument, if you do something like that, this 90, it's a sorry, I forgot one thing. This 30, this entire angle is 120, therefore this is perpendicular. By the same argument, this perpendicular, this angle is 30, 30. This is a hexagon though, right? Hmm. Now, we can take the moments. Let's take the moments about A. In this side, the moment is 0. Here, you don't have to take the moment for this one because it's so, I mean, it goes through A. You have to take the moments for these 4. Now, this way, 4 is positive. This is the length. What is that length? 2A cos 30, right? Adjacent side. Now, what about this? P plus P. Now, if you drop a perpendicular, now it's an isosceles triangle. This triangle is congruent to this. So this also 2A cos 30 because this angle is 30. This another 2A cos 30. So 2A cos 30 plus 2A cos 30, 4A cos 30 to this one. For 10, again it is positive. By the same argument like this. 2A cos 30, 2A cos 30. It is 4A cos 30. Finally, Q. It's minus Q. This is the length. This side is 2A. This is a perpendicular distance, 2A cos 30. Now divide everything by 2A cos 30. Don't divide it here in the next line. 2A cos 30. This gone, you get 4. You are dividing this by 2A cos 30, so this will give you 2. You are dividing this by 2A cos 30, so that will give you another 2 minus Q. So this is 4, this is 20, 24. Bring it to this side. Minus 24 is 2P minus Q. Now get another moment about D. This is 0. Right? And you don't have to worry about these two. They are going through D. But there are another 3 forces. If you extend this, again do the same thing. Drop a perpendicular. This is, 30, 90, 30. Because, it happens because, this angle is 120. Oh, sorry. This is 60. This angle is 120. So this is straight line. So this should be 60. This is 30. So 2a cos 30 is the perpendicular distance. For this, you do the same. This 120, 60, 30. That's a perpendicular distance to that force. What's the other one? This one. It is simply this, like in this case. 2a cos 30, 2a cos 30. So we'll take the moment. You don't have to worry about 10 and p. We'll start with 3. 3. This way, positive. Perpendicular distance from D is this 2a cos 30, 2a cos 30. So 4a cos 30. For this, again, it is positive because when you take the moment, it is in the positive direction. 4 times. This is the perpendicular distance, 2a cos 30. This is the adjacent side. So we are done with these two, and we have to take this. We will take the moment this way, it is negative. Minus q times this is the perpendicular distance. 2a is 2a cos 30. Divide everything by 2a cos 30. 3 times 2 plus 4 minus q. So q is 10. Now when you plug in 10, you can find p. Minus 24 is equal to 2p minus q. So if you bring 10 to this side, it is 10 minus 24, which is minus 14. P is minus 7. There's a shortcut way of doing, getting these perpendicular distances in the case of a regular hexagon. This is how you do it. Sorry. Right. This is a shortcut method of doing it. Say A. Rather than, doing all those lines and stuff like that, you can straight away do it like in this fashion. Now, if you take these two lines, so any force acting along these two sides, the perpendicular distance from A is 0. It goes through A, right? From A, our distance from A, we are considering the distance from A. Basically 0. Because those two goes through A. Therefore, no distance. I'll draw it like this. No distance. Then next level, there are two lines. These two. EF and BC. Now say this 2A. This 120. Therefore, this 120, this 60. So you get 30. Basically, 2A cos 30. And you can see that always, the distances are either 2A cos 30 or 4A cos 30. Right? Now, let this be D. That is 2A cos 30. There are two sides which are sitting far away from A. Those are DE and CD. That is 2D. Basically 4A cos 30. If I draw the distances from the thickness, like they are like this. Like this 0, 1 and 2. සිංහල වලින් මේක සිංහලෙන් ගන්න පුළුවන්. සිංහල ලැන්ග්වේජ් එක මම ඔයගොල්ලෝ හැවි එකයි. සිංහල වල තියෙනවා මොකද්ද? උත්තම පුරුෂ, මධ්‍යම පුරුෂ, හා ප්‍රථම පුරුෂ. තුනක් තියෙනවා. උත්තම පුරුෂ වලට දුර කොච්චරද? උත්තම පුරුෂ වලට දුර ඒක දුරක් තියෙනවා. දුර කියන්නේ කොහොමද? ඒ නාමපද විදන්න පුළුවන්. උත්තම පුරුෂ, මධ්‍යම පුරුෂ, හා ප්‍රථම පුරුෂ. උත්තම පුරුෂ වලට දුර කොච්චරද? උත්තම පුරුෂ කියන්නේ මොනවද? මම හා අපි. මට තියෙන දුර මොකද්ද මගේ ඉඳන්? බිඳුවයි. අපිට තියෙන දුරත් බිඳුව. අපි ඔක්කොම එක ගෲප් එකනේ බිඳුවයි. ඒත් මම හා අපිට දුරක් නැහැ. මේ වගේ. මේ සෙට් එක. මේකනේ උත්තම පුරුෂ ලෙවල් එකේ තමයි තියෙන්නේ. ඊගොට තමයි මධ්‍යම පුරුෂ. මධ්‍යම පුරුෂ කියන්නේ මොන අයද? අපිම නෙමේ අනිත් සෙට් එක. හරිද? අපි එක්ක පේන්න ඉන්න සෙට් එක. අපිට ඒගොල්ලන්ට බනින්න පුළුවන්. මොනවද? ගහන්නත් පුළුවන්. හරි. ඒක ළඟපාත ඉන්නවා. හැබැයි අපේ සෙට් එක නෙමෙයි ඒගොල්ලෝ. දැන් ටීම්ස් දෙකක් ගහුවොත් ඔපොසිෂන් එක. එහෙම නැත්නම් අනිත් ටීම් එක. ඒ කියන්නේ ඒගොල්ලෝ අපිට පේනවා. අපිට කතා කරන්න පුළුවන්. තූ තොපි නුඹ නුඹලා කියන්නේ ඒගොල්ලෝ. කතා කරන්න පුළුවන්. ඒගොල්ලෝ අපේ සෙට් එක නෙමෙයි හැබැයි. අනිත් අය. අපි නම් නේබර්ස්ලා. එක්ක ටීම් එකක් ටීම්ස් දෙකක් නම් ඔපොසිෂන් එක. අපේ ටීම් එක අපි. ඒකට දුරක් නැහැ. අරගොල්ලෝ අනිත් කට්ටිය. ඒව තමයි මේ මොනවද? මධ්‍යම පුරුෂ. ප්‍රථම පුරුෂ කියන්නේ ඒක අර ජස්ටි ෆාර් වේ. මෙහෙම මේ කට්ටිය. ඒ කියන්නේ ඒගොල්ලෝ අපිට පේන්නේ නැහැ. අපිට අර මධ්‍යම පුරුෂ කට්ටියත් එක්ක අරගොල්ලන්ට බයින්න පුළුවන්. අර ඒ කියන්නේ ඕහු හේ එහෙම කට්ටිය. ඒ කියන්නේ අපි ඕහු හේ පාවිච්චි කරන්නේ නැහැ. උන් මුන් කියලා කියන්නේ ඒ අනිත් කට්ටිය. උන් කියලා කියන්නේ මුන් නෙමෙයි. උන්. මුන් කියන්නේ මේගොල්ලෝ. පේන්නේ නැහැ. ඒතර ඒගොල්ලෝ මධ්‍යම පුරුෂ. උන් කියලා කියන සාමාන්‍ය නැති අය නැති භාෂාව එහෙමනේ කියන්නේ කතා කරද්දී. We don't, it's not a polite way of calling people though. පොඩේ. හරි. දැන් මේ 25 ක්ලාස් එකේ ඉන්නවා. එහෙම හරි පොලයිට් එකා. මාරු පොලයිට් හැබැයි ටැමිල් ළමයි. ඒතර එයාට මේ ලැන්ග්වේජ් එක හැම වචනෙම බෑ. අද මොකද එහෙද මෙයා පොඩ්ඩක් පරක් වෙලා ආපු ඉඳ ක්ලාස් එකට ඔයාලා දැන් කොහොමද මේක මං කියලා දෙන්න කියලා නෑ. මුගෙන් අහගන්න මං කිව්වා. එයාගේ තියෙන vocabulary ඉතින් මූ කියලා කියන්නේ කී කියන එක තමයි මූ මුගෙන් අහගන්න. ඒ කියන්නේ එයාගේ මං කියන්නේ එහෙමනේ කතා කරද්දි කියන්නේ. ඒතර මූ කියන්නේ මධ්‍යම පුරුෂ ළඟ ඉන්න එක්කෙනා. ඌ අර එහා පැත්තේ ඌ කිව්වොත් වෙනස්. ඌ එහෙම තමයි. අරු උන් කිව්වොත් ඒක සාමාන්‍යයෙන් අපේ ෆෝමල් සිංගල් ලැන්ග්වේජ් එකේ පාවිච්චි කරන්නේ නැහැ. they are not very polite though. හරිද? හැබැයි පාවිච්චි කරන්නේ එහෙමනේ. ඒක තමයි මධ්‍යම මේ ප්‍රථම පුරුෂ. ඒ ප්‍රථම පුරුෂ සෙට් එක තමයි ඈතින්ම ඉන්නේ. they are not visible. ඒ අපිට පේන්නවත් නැහැ. පේන්න ඉන්නව නම් අර තෝතපි නුඹරවලක අපිට ඇඩ්‍රස් කරන්න පුළුවන් කට්ටිය. they are not us. මමවත් අපිවත් නෙමෙයි. හැබැයි අපිට ඇඩ්‍රස් කරන්න පුළුවන්. ඒගොල්ලන්ගේ මෙහෙම ඉඳලා කතා කරන්න පුළුවන්. දැන් අපි පොලිටිකල් මීටින් එකට ඇවිල්ලා ඉන්න කට්ටිය. ඒගොල්ලෝ. හැබැයි අපි මෙතන පොලිටිකල් මීටින් ඉන්නකොට වෙනත් මීටින් එකක ඉන්න කට්ටිය ඒ ප්‍රථම පුරුෂ. උන් මුන් වගේ උන් වගේ ඒගොල්ලෝ. ඔව්හු එහෙම හේ ඇය ඔහු එහෙම අය. ඒතර ඒක මේ ඊගාව ලෙවල් එකේ තියෙන ගොඩක් ඈතින්. ඒතර මම අපි කියන්නේ මේ එකට ඉන්ටර්සෙක්ට් වෙන ලයින්ස් දෙකට there's no distance. In the next level it's like මධ්‍යම පුරුෂ. පොඩි ඩිස්ටන්ස් එකක් තියෙනවා මේක ප්‍රථම පුරුෂ. ඒකට එහා. ඒක හරියට මේකේ ඩබල්. 0D and 2D. එහෙම ගත්තම නිකම්ම ගන්න පුළුවන්. මේක වෙන නිතර එන්නේ ප්‍රොබ්ලම්ස් එහෙම આવොත් ඔහොම ගන්න පුළුවන්. ඒතර මාර ඇඩ්වාන්ටේජ් එකක් තියෙනවා මෙහෙම ගත්තොත්. මොකද අනිත් වලට ඉක්මනින් හදන්න පුළුවන් හින්දා. right. So basically that's it. මේකේ මෙහෙම આવොත් you have to take the moments about A and D because the resultant is going through A and D. But if you don't like to take many moments, this is how you could have approached it. Start with this D, because you know when you take the moments about D, P will go away, so you can find Q straight away. Then rather than taking a moment about A, because when you take the moment about A, you have to consider four forces. Otherwise that you can resolve forces. Here you don't have, you have to put an extra effort because you already have them here and here, these two places. So their ratio should be what? Y over x is what? Y over x. Y over x. It is 60, tan 60. This is y, this is x. So y over x is tan 60. From that you can find the other, you can obtain the other equation. That's one way of doing it. Okay. If you don't like to take so many, moments like this, but if you have this shortcut method at your disposal, this would be, this method would be handy. But this won't be very handy if you try to go, go through, handy or profitable or more effective. If you have to find all these distances, then probably first take the moment about D, and then rather than taking the moment about A, you use these two. Y over x is tan 60. From that you can get it done. Right. Now we'll move to another problem. B. We'll do in trig, we'll do part B and part C. Okay, first using the formula for tan A plus B, obtain a formula for tan 2 here. That's simple. Now, if you want to obtain tan 2 theta, let A and B be equal to theta. You get 2 tan theta over 1 minus tan squared theta. That's quite straightforward. And then we need to obtain a formula for tan 3 theta. Again, apply the same formula. I mean, you don't have to go this far. You can write it like this. Now, plug in this formula for tan 2 theta. If you want, you can use a substitution like T for tan theta. Otherwise, you have to write a lot of letters. Like tan theta means how many letters? 4 letters, 4 characters. So go for this. Now you can multiply each and every term by 1 minus t squared. 1 minus t squared. So this is gone. When you multiply this by 1 minus t squared, you get that. Multiply this by 1 minus t squared. Then this is gone. When you multiply it by 1 minus t squared, you get 2t squared. So basically that's it. 2t plus t, 3t. Or t times t squared, t cube. 1 minus, you can combine these two. Now, show that tan pi by 18, okay, is a root of something, right? Now, there are two things that we need to show. Tan pi by 9 is a root of another equation. So we have to, okay, this is what we need to do. Now, if you want to show that something is, say for example, if you want to show that 2 is the root of this, 2 is the root of this equation, I mean, rather than solving it, you can show this. 4 minus 6 plus 2 is equal to 0. So that goes hand in hand with this equation where x is 2. So 2 is is a root of this equation. So we use the same strategy here. Now this is tan pi by 6. That means tan 30, which is 1 over square root 3. I'll take this as x. Pi by 18 means tan 10. Now cross multiply. So it is 3 square root 3x. Now bring everything to one side. So let's take everything to the left-hand side. This is minus 3x squared. Bring that to the other side. This is plus 1. So by the same argument, therefore, uh, now x is tan 5 by 6, 18, right? Is equal to 0. It is exactly like that. Like say, if you have 2 squared minus 3 times 2 plus 2 is equal to 0. Now plug in x is equal to 2. Now you can say that uh, 2 is the root of this equation. But it doesn't mean that there are no other roots. Here, there are 2 other roots. We don't know what they are. Similarly, you can play with pi by 9, right? Okay, right. Using the law of sine, part C. Need to show the following. We'll rearrange this. We'll have, I'm not sure how this works. We'll see how it's going to be unfolded. So we'll start from this side. Now you have to, I mean, by sine rule, you can claim the following. Any side is proportional to its sine of the opposite angle. Seems like I should obtain this. Just hold on, no? 690. Right. Now you can write this as sine A plus sine B, sorry, sine C over sine B. We can apply a CD formula and see what. What's going to happen? 2 sine a plus c over 2 right. Now this side, you have two, I mean, you can apply the double angle formula for, in fact, half angle formula. You can write it like that. Hmm. These two will go away. Now, you can cancel one of these. But for that, you have to substitute like a plus b plus c is 180. So a plus c is 180 minus b. Now look, this is in fact 90 minus b over 2. Sine 90 minus theta is cos theta. So this cos theta, cos b over 2. This will go away with this. Now what we need is the following. We need this. So we need another sine b over 2 for sure. We have one sine b over 2. We need another one to make it a square. So we'll multiply both upstairs and downstairs by sine b over 2. Now we are done with this. We have sine squared. Now look, in the upstairs, this is what you need. So it's kind of a CD formula. So one term should be like 2 should be there. 2 cos a plus b, sorry, a plus 2 over c times cos a minus c over 2. Cos a plus c over 2, cos a minus c over 2. You have cos a minus c over 2. So you need to write this guy in terms of a and c. Again, do the same thing. You can write sine b over 2, right? Uh, Sine b over 2 as 90 minus a plus c. Not 90. 180 minus a plus c, quantity a plus c divided by 2. Now this is 90 minus this angle. Sine 90 minus that angle is cosine. Because sine and cosine are co-functions. So 90 minus thing is cosine a plus c over 2. Now this is cos a plus cos c. If you apply the CD formula in the reverse direction. So we started from the right-hand side, we get the left-hand side. Right? So mainly you have difficulties in those.